I'm now joined by Dr. Paul Schenk of the Lunar and Planetary Science Institute, who was just on the panel discussing the latest results from New Horizons. And Paul, what an exciting result we had today.
Well, yeah, we're all giddy about it, so quite excited. But I know we got lots more wonderful stuff to come. This was really just a teaser, like going to Disneyland and just seeing it from the freeway. You really want to go inside.
What, again, is the resolution that we're currently looking at right now?
Best resolution is about 140 meters, which I don't know what that is in feet. I can never do the translation, but it's we're talking a football field size.
So
a bit bigger than that.
That is to say, each pixel of the image represents about a football field's in length.
Right. So we're not resolving the seats in the stadium. We're just seeing that there's a large object the size of a stadium there.
Understood. And it really does start to somewhat pop a little bit as three-dimensional when we put on the red-green glasses. Right. Can you tell me a little bit more about how that was accomplished and what other stereo imagery you're looking to get out of New Horizons?
Well, the image that we showed today is from two images that were taken on approach. And we really weren't expecting very much from this because we knew we were a long way away and we knew what was coming up. But we assembled them anyway just to see what anything could be resolved, because we didn't know on approach, even last week, we didn't know what the rotation was. So,
right.
So we're actually seeing in the stereo pair a little bit of the rotation of the body underneath the camera, as it were. But also showed, which is more effective, I think, is the blink.
Yeah, I thought that was cool.
Between the two, you can actually see the motion between them. The stereo is kind of fuzzy and difficult to use. It's not ideal, again, because we don't have the images downlinked yet.
Right.
But that's how we got that, and we wanted to show it and sort of let people know that more interesting things are coming on the way. We're expecting the best resolution to be about 30 meters, which is better than a football field.
Absolutely, and to be absolutely clear, we are not talking about an actual football stadium in the Kuiper Belt.
Yeah, well, no.
Although...
highly unlikely.
But can you be sure? Can you prove there's no? Because, I mean...
I'm not going to comment.
All right, fair enough.
I mean, you think Lambeau Field in Green Bay is cold. This is like, oh my God. This is really bad.
This is absolute zero.
Yeah, this is really bad. Yeah, so nobody would want to play or go to that game. But anyway, we're anticipating that, Alan mentioned it, that we think the pointing was actually really good, because we updated the software on board just before the encounter to correct any disturbances in the trajectory. We think it's going to be probably spot on. So the stereo images at highest resolution will cover most of the surface. And those will create stereo images with the preceding mosaic. So that will give us resolvable features. We'll see craters if there are any. We'll see ridges, scarps. Anything geological of that type should be visible in those images.
Is the thumbnail image that we're seeing right now, does that represent the image taken during closest approach, or are there...
The ones we released today?
Yesterday and today.
Oh, no. I think we're about an hour away from closest approach. So we're coming in at 14 kilometers per second. And, your students can do the math and figure out, what
get to work, guys.
Closing rate, what that actually amounts to. So we're quite a ways away in terms of a small body like this. I mean, Pluto, we could get further away and still see the whole sphere and map out the geology. Here is such a small structure, we got to get really close to see much.
So, of course, the closer ones will have higher spatial resolution, but really the close-up images have yet to come down.
That's right. And we're expecting the first of those to be sometime in the first week of February, if I remember correctly, somewhere in that time frame. We have to wait for the solar conjunction to pass, because Pluto's behind the sun, so the radio signal's blocked, so we're not going to get anything for a while.
Would you expect craters? I mean, when we look at craters on the moon, we have these nice sharp-rimmed that are the result of these very high-energy, high-velocity impacts.
Right.
But in such a weak gravity environment, would you expect to see those high, sharp-ridged, high-velocity impacts?
The key here, in terms of whether we see deep craters with steep rims, is really more a question of velocity. We've seen quite a few of the Saturnian icy moons that orbit near the ring, and they're about the same size, and they have very sharp craters. but they also are subject to much higher impact velocities, like 15 to 20 kilometers per second.
Right, because they're in the ring system.
Higher. And Saturn's gravity pulls those projectiles in, and they go wham. Here, the impact velocities might be 1 kilometer per second or less, which means they're somewhat slower. And there are some predictions that you might not even get a crater, you get a mound of boulders instead. So we're going to be
just settling on the surface almost.
Yeah, hitting but not making a big explosion, just making a big splat without exploding.
Based on the thumbnails that we've gotten so far, are you leaning more in that direction, or is it really anybody's still a guess?
Yeah, way too early to tell because we haven't seen the resolution to see the small craters that we need to test that with.
We were talking earlier about the stereo work for Ultima. Obviously, you've done stereo work on other stuff other than just Ultima. So tell us a little bit more about the kind of work you've done and where we can find it.
Yes, indeed. I've done a lot of stereo mapping in my career, which spans basically the early 80s till now, focused almost exclusively on the icy satellites of the giant planets. And we have got so many images of the Saturnian system, for example, that we can do stereo images of almost the entire surfaces of all the moons. What you can do with that, of course, is you can view them in stereo, which tells you a lot about the geologic relationships. But you can also use those in the computer to derive the heights and elevations of individual geologic structures across the entire stereo scene and construct a bump map for those terrains. And the bump map is basically an elevation map. You can put that into software. This is software we didn't have in Voyager days, 1989. None of this was around. But nowadays you can use it on your laptop. And what you can do is take that and drape that with the image and create a surface that you can project digitally. And what we've done is to actually animate that to create movies as if you're flying an airplane over the surface of Europa or Enceladus or Triton or one of those other moons. They're very dynamic and they show the relief, and you get a real sense of being on a planetary surface rather than these sometimes the still black and white images that are released look pretty, but you really don't have a sense of what's going on, what's high, what's low. And I spend a lot of time putting those together because I love stereo imaging.
Okay, well, guys, this is really cool. I just want to thank Paul Schenk once again for joining me on Launchpad Astronomy. Thank you again, sir, and congratulations on an amazing accomplishment.
We had a big team, and they did their job wonderfully.
Absolutely, and it really is a team effort. So kindly make sure to subscribe and ring that notification bell so that you don't miss out on any new videos. Until then, my friends, stay curious. I'm such an idiot. All right, try this again. Sorry about that.
That's good. I can work this.
We could do another take on that. Appreciate your patience.
It'll cost you.
I know. I'm so sorry. This will end up in the blooper reel, I bet.
Well, no, you didn't record it. Oh,
yeah.
the microphone.
No, I was recording, but without the microphone.
Now I understand.
Sorry.
No problem. I've made that mistake.
I don't know what I'm doing.